Welcome students. In the previous class we discussed about what is simple machine and what are the functions of simple machine and why we use in generally simple machine in our daily life. Now today we will discuss about what is mechanical advantage and what is mechanical advantage, which is in short form is MA, and what is efficiency, and we know about different types of machine and know about labor. Okay. So at first we have to know what is mechanical advantage. Now before knowing the definition of mechanical advantage, we have to know about two terms. First one is what is load, and the second one is what is effort. Okay. So at first, what is definition of load? Actually, load is one type of force. It is, we can say it is one type of force. Type of force that is actually used by the machine on a object. Okay. And another question is what is effort? It is also one type of force. It is also one type of force that is mainly used on a machine. Okay. So what are the or what is the basic difference between load and effort? Actually, load is one type of force that is act on a object, and what is effort? Effort is one type of force that is mainly used on a machine. Now the question is, what is mechanical advantage? Actually, mechanical advantage is the ratio of load and effort. Okay, or we can say mechanical advantage is equal to load upon effort. Okay, so that means it is the ratio of two force. Okay, load is one type of force and effort is also one type of force. So if we want to know what is the unit of mechanical advantage, actually what is the unit of mechanical advantage? Unit of MA, as we can say, this is load upon effort. So what is the unit of load? Actually load, that is force. So Newton upon effort. In SI system, the unit of effort is also Newton, as it is force. So unit of mechanical advantage is equal to ultimately 1. That means we can say MA is unitless quantity. Okay, so here is the concept. Actually, mechanical advantage is ratio of two types of force. One is load and another is effort. Now we have to know our second part, which is efficiency of a machine. So question is, what is efficiency? Okay, what is efficiency of a machine. Actually, efficiency is equal to actually output energy, output energy divided by input energy. That means we can say it is the ratio of two types of energy, and it is the ratio of output energy to input energy. So efficiency is obviously unitless quantity. It is also unitless quantity. Now, if we find out what is the percentage of efficiency, then we can say efficiency, if we want efficiency in percentage, then we can say output energy upon input energy into 100 percentage. Okay. So what is the actual meaning of efficiency? If we want to know what is the actual meaning of efficiency, then we take a simple block diagram like that. If we take, this is a machine. Okay, this is machine. Okay, and we use input energy. This is your input energy. Here we use input energy like this is say 100 joule. Okay, so we apply 100 joule energy to the machine, and we get a feedback from this machine is 80 joule. Okay, we get 80 joule. So here 100 joule is actually input energy. Okay, and here 80 joule is actually output energy. So what is the efficiency of that machine? Actually, efficiency is equal to output energy 80 divided by input energy 100. That means we can say zero point 0.8. Okay, efficiency. If we want this result in percentage, then what is the percentage? Efficiency in percentage actually, in percentage, then we can say output energy, that is actually 80 joule divided by input energy, which is 100 joule, into 100 percentage. So we can say 80 percentage. So from this type problem, we can easily find out what is efficiency of that machine or of this machine, and we already find out how efficiency is calculated from this figure. Okay, so now the question is, where actually, where about 20 joule? Okay, that is actually energy loss. Okay, so here if we find out what is energy loss, that is equal to input input energy minus output energy for a machine. So here from this problem we can take input energy as 100 joule and output energy is equal to 80 joule. So energy loss for this machine is 20 joule. Okay, so if we apply to this machine is 100 joule and we get 80 joule, then we can say energy loss for this machine is 20 joule and efficiency is zero point 0.8 and efficiency in percentage is 80 percentage. Okay, now we take a problem how we find out actually mechanical advantage. Okay, So in this case, we take a problem like at first we take a simply a machine. This is your machine. Okay. For this machine, we applied a load which is basically we can say suppose 50 Newton, and in this case effort is actually we can take 25 Newton. So what is the value of mechanical advantage? Actually, mechanical advantage is equal to load upon effort. Okay. So for this case, actually we know load is equal to 50 Newton and effort is 25 Newton. So mechanical advantage of the machine is actually 2. Okay. This is one condition, and we take our second condition, that is actually we take second condition. This is take load is equal to simply 50 Newton and effort is equal to 100 Newton. Okay, so here mechanical advantage is equal to load upon effort, that means 50 Newton upon effort means 100 Newton, that is equal to zero point 0.5. Okay, and we take another condition which is third one. In this case we take load is equal to 50 Newton and also effort is equal to 50 Newton. Then mechanical advantage is equal to 50 Newton divided by 50 Newton, that is equal to 1. Okay. So here we take three conditions. First one is actually mechanical advantage is equal to 2. So this is actually greater than 1. Sorry. This is actually for this case we take mechanical advantage, this is greater than 1, and second one is zero point 0.5 which is less than 1, and the third one is actually equal to 1. So from these three types of concept, or we can take three types of problem and know about actually three conditions. Okay, first condition is when load greater than effort, then we can say mechanical advantage greater than 1, and the second condition is when load is less than effort, then we can say mechanical advantage less than 1, and the third condition is when load is equal to effort, then mechanical advantage is equal to 1. Okay, if actually mechanical advantage of a simple machine is greater than 1, then we can do some hard work with the help of this machine. Okay, or we can use less effort and do some hard work. Okay, so this is the basic concept of mechanical advantage and efficiency. Okay, Basically, mechanical advantage is the ratio of two types of force, that is load and effort, and efficiency is the ratio of two types of energy for output energy to input energy. Okay, now we move our next point, that is in your syllabus there are several types of machines. Okay, so here are these points. Actually, there are actually six type of there are six type of machines. Okay, so first one is actually, here we can take first one, A, that is lever. Okay, and B, this is inclined plane, and C, that is actually pulley. Okay, and fourth one, that is screw, and fifth one is OH, and the sixth one, wheel and axle. Wheel and axle. Okay, so these are the six types of machine that is generally used in our daily life. Now the first question is, what is lever? Actually, first question is, what is lever? Basically, a lever is a simple machine consisting of a beam or a rigid rod pivoted at a fixed hinge or fulcrum. Okay, the fixed hinge is called fulcrum, and a lever is, again we can say, a lever is a rigid body capable of rotating on a point on itself. Okay, now actually general diagram of a lever is like that. We draw a simple diagram here. Actually, this is your simple diagram. If we take like that, and here this is a fixed hinge, this is defined as F. Okay, and is one force is applied, that is called load, and another force is effort. Okay, so here we also know about what is actually load arm and what is actually effort arm. Okay, from this figure, the distance between load and fulcrum is called load arm, and the distance between effort and fulcrum is called effort arm. Okay, so from this case we can say LF, actually the load and fulcrum, LF is called load arm, and E and F, that is effort, distance between effort and fulcrum, is called effort arm. Okay, this is your definition of load and effort arm. Now, what is the principle of lever with mechanical advantage? In general principle is, this is the general principle. Actually, load into effort load arm is equal to effort into effort arm. Okay, so the that is the simple principle of a simple lever. Okay, with mechanical advantage. In generally, here are the three conditions. First condition is, if load arm is equal to effort arm, first condition, then we can say this is your first condition. When load arm is equal to effort arm, then mechanical advantage is equal to 1. And the second one is, when load arm is greater than effort arm, then mechanical advantage is less than 1. That is your second condition. And the third condition is, when effort arm is greater than load arm, then we can say mechanical advantage is greater than 1. Okay, so from these 3 points we can easily define that lever has several number of mechanical advantage. Maybe it is equal to 1, maybe mechanical advantage of a lever is less than 1, maybe lever has mechanical advantage which is greater than 1. Okay, and there is also three types of lever. Okay, so lever are in generally three types actually. First one is, we can say, class 1 lever or first class lever, class 1, and second one is class 2 or second class, we can say second class, and the third one is third class lever. Okay, so in generally actually, what is the basic difference between first class, second class and third class? Actually, it is based on mechanical advantage. Okay, so in this PDF actually, here you can see these are the examples of first class lever. Okay, in this case actually first class lever, fulcrum is situated in between load and effort. Here this is your load, this is load, and this is force applied on the machine, that means it is effort. Okay, and fulcrum is lie in between load and effort. So in that case actually, for first class lever we can say, for first class lever we can say mechanical advantage is equal to 1, mechanical advantage less than 1, mechanical advantage greater than 1. Okay, that is actually depend on the length of arm. Okay, load arm and effort arm. Okay. Here are the different example of first class lever, and for second class lever actually at first we draw simple block diagram for first class lever. Okay, this is your first class lever. At first actually in this case these are fulcrum, and here we use load and one end is effort. In this case mechanical advantage equal to 1, mechanical advantage less than 1, and mechanical advantage greater than 1. There are three possibilities for first class lever, and for second class lever actually, for second class lever actually the basic block diagram is like that. Fulcrum is situated one end and load is applied middle, and another end is applied effort. So in this case actually always mechanical advantage greater than 1. Okay, because here always effort arm, always effort arm greater than load arm. Okay, and if we take third class, then in this case actually we use one end fulcrum and another end load, and in this mid range actually effort. Here always mechanical advantage less than 1, and we can say load arm is greater than effort arm. Okay, so and we also take different types of example, like this is the example of first class. These are the first class example of first class seesaw. Okay, this is first class. This is actually first class liver, and if we take second class, then we get actually this type of example, like this is second class, and if we take third class, then actually these are the third class liver. Okay, so here we actually get some basic idea of three different types of liver. Okay, and we know what is the principle of liver with mechanical advantage. Okay, in the this is the end of today's class. Okay, in the next class actually we discuss about these three types of liver in broad way, or we discuss in with the, we discuss with the help of different types of problem. Okay,